welcome back for episode 2 of the Gantry crane build. If you haven't watched the first episode, go back and check it out. It's basically I get the majority of the materials cut down to somewhat size, get most of the rust scale removed from the used steel. And so as I mentioned off camera, I was going to, after I cut one to length, and you've seen that, you didn't need to see that 7 more times. So as I mentioned, I got the other miters cut on the other 7 pieces, got them dressed up with a grinder a little bit, and so then I laid out the dimensionally what everything was supposed to be, width, the height, all of that on the trailer, made some Sharpie marks on the trailer, and then I rolled or set the pieces into place. So I'll kind of lift you up here and give you a bird's eye view. One advantage to CAD is, assuming I don't make mistakes on the entry, it doesn't lie, it's just math. So in the old days, if I was to build something like this, I would have had chalk lines and tape on the floor and built it on the floor. So it's nice to build it, as I mentioned before, in a virtual world to make sure everything works out, and then come out and see that those measurements played out correctly. So without further ado, let me raise you up here so you can get a view of what overall what one frame looks like. And I'll bring you in here a little bit closer so you can take a look at some of the joints. Again, these were just freehand with a torch, and then I dressed them up with a grinder. So what I did is I basically used the bottom edge of this trailer. It's a nice, really square trailer, so the bottom edge would be the equivalent of the ground. I measured over what the width of between the 2 legs is supposed to be, centered that beam in the middle of that span, pushed that beam up to the height it's supposed to be, and marked a center point on the bottom of the beam here. Bottom of the beam as well as up on the top, so it's centered within the trailer. And then I just slid everything into place, and those angles there lined up pretty darn good, because there will be a flat plate across here that the caster sit on. Those angles lined up good, and then you can see up the middle, they're not even pulled in tight, so there's a little gap there on that one, but it's an even gap all the way around. So when I pull that in tight, so the good news is all the miters worked out correctly. So I've got a little bit of, I'm going to clean some of the paint off of that square tubing where I'll be welding. And then I'll bring you back here and we'll talk about how I'm going to try to hold everything where it belongs. The tubing, these tubes, as I mentioned, they're like right at 3 inch. And so is that square tubing. There's slight variation. So the good thing is basically with everything sitting on the trailer, that kind of puts it in the right elevation. At least I might have to do a little shimming here or there because of the diamond plate. But for the most part, once I get everything laid out here on the trailer where it belongs, then I can tack things in place, and then I'll just make a duplicate of that. And that way it kind of guarantees it's flat, versus if I tried to stand this up and do it, it could really get out of flatness pretty easily. So I'll clean that paint up, and I'll bring you back here in a little bit with a little bit more setup and maybe some tack welds. Okay, so I just finished up grinding the weld prep on all 4 of those first tubes that we fit up. Probably wouldn't have had to have one. I could put a big enough fillet in there, but never hurts to have a little bit of a chamfer cut to give a place for a little bit better penetration. So, of course, the furnace comes on right when I start talking. So I'm going to grab that top tube there, get that cut to length. That's 58 inches long it needs to be, and lay out the holes. And then it'll be time to kind of fit everything back together as snug as I can and tack weld things in place. So let me get you set up over the drill press and we'll get some holes drilled. Okay, got you set up over here at the drill press. I'll pan you down. Not that drilling holes is anything special. Actually, you see there the press in the background. So if you hadn't seen that episode, go back and check that out. I built that press from scratch. So off camera, you can see here some of the paint's missing. I went ahead and cleaned off the paint in the areas where I'm going to weld. I laid out the locations I need to drill, and then use the optical center punch to punch those, given to try to get as accurate as possible. As far as pin size, what this is for is for the pins that will hold the extendable portion at different heights. In the fully collapsed position, it will fit out my shop doors, or actually will fit underneath the overhead door tracks. And then there's a couple more positions, so if I could get up, if I'm outside or something, I could raise it even higher, or if I'm clear of my garage door tracks, then I could also raise it up all the way against the ceiling. So anyway, I've got those 3 holes laid out. I'm going to drill those, and instead of drilling also through the piece that will telescope up and down, there's really no need to, because gravity's always going to hold it in place. It will just come down and sit on top of the pin, similar to how the table on the press works. As far as diameter of pin, I'm only going to use a 1/2 inch pin. Before some of you think, ooh, that's not nearly strong enough, I think I actually might even just use a bolt, and that way it's bolted in there, it can't fall out. Think about a trailer hitch or receiver hitch. Those are a 5/8 pin in a class 4, and you can, I don't remember what the maximum upper limit is on a class 4 hitch, but it's in excess of 10,000 pounds. So you have that much pulling force. Not only that, but heavy braking, jerking around on a 5/8 pin holds that much weight perfectly. Since this is a 1/2 ton, I'll probably rate this. I mean, I think this would easily hold 2,000 pounds, but the winch that's on it, or the chain hoist that's on it, is only 1,000 pounds. So the most either side would see would be 500 pounds, give or take. So a 1/2 inch pin will be, I could probably go clear down to a 3/8 or even smaller, but I'm going to do 1/2 inch. So let me get your pan down here and we'll get these holes drilled. I'm just using a small pilot bit, and then I will switch to I kind of prefer the unibits, because then they don't make a kind of a 3-sided. When you start making bigger holes, a traditional drill bit almost tries to make a 3-sided or 6-sided hole, so I'm going to use a unibit to do that 1/2 inch hole. Let me go grab the other bit. And if you've never used a unibit before, of course they have several different sizes on it, and the way I kind of keep track of which size I'm on is I just look at that's graduated on the side of the bit. So a 1/2 inch, let me double check. 1, 2, 3. Yeah, the 1/2 inch diameter is the 6th step up, so I just keep track of how many times I go to the next step. The other nice thing about the unibits is because there is the next size up over that, you can come down and just touch that next size, and then it puts a chamfer, takes the burr off of the previous hole. Okay, so that's it for the prep on this piece. The paint's off. All you gotta do is cut it to length. I'll do that real quick, and then we will get going on some welding. Okay, so I'm ready to glue this together, but before I do, I kind of want to go over a little bit of the setup, how I kind of clamp things in place, which is another reason why I don't like dealing with pipe, because if this was all square tubing, everything lays a lot flatter. It's easier to clamp to, things like that. So because I know the trailer deck is very square, I was using the bottom here as a reference, as if that was the ground, sitting on the ground, and I measured out to the center line of that tubing, marked a couple lines there, so I know that tubing is sitting dead center as far as the width goes. The bottom is spaced out the amount it's supposed to be, and so in theory, sitting on the trailer like that would have worked fine, but because it's round pipe, it wants to always kind of move Again, you can't clamp it. If this was a steel trailer, I would have just put it, as I put it in place, I would have either just tack welded it to the trailer deck itself that I could cut loose later, or put welded a couple little stops on the trailer. But since it's aluminum, that doesn't work. I guess I could have welded some aluminum stops on there. But so what I did instead, I'll pan you down here, is I scooted it out. I came out off the trailer this direction, exactly 3 inches on either side. So that's the same. I don't have the base of the trailer anymore as a reference point, but because I came out 3 inches, in essence, I just scooted everything this way 3 inches. And then what that let me do, as you can see here, that let me put a piece of angle iron across, and I can clamp to those, and that does 2 things. One, it keeps the pipes from rolling, and secondly, when I put the mounting plates for the casters on here, you want those basically perfect, not basically, you want those parallel with the ground as much as possible. It was just a round wheel that was not a swivel style caster. I don't know if I have an example here. If it was just a round style or non-swiveling, it really wouldn't matter as much. But on a swiveling caster, for instance, this isn't what's going on, but a swiveling caster, because the wheel offset is different from the axle or the pivot point, if you can imagine, if it's set like this, that wheel's going to automatically want to swing around and find the lowest spot. So on swivel casters, which this will have, it's important to have those mounting flanges as parallel to the ground and as parallel, or on the same plane at least. So that's the other thing that angle iron does, is it gives me a spot to scoot all 4 tubes down to. So I know that they're on the same plane, and so then when I weld those mounting plates on, that won't be a problem. I'll probably tack weld them to the angle, but then I'm just going to tack weld these pieces of 3/4 inch square tube just temporarily on there. I'll cut them loose later. That will hold everything kind of those, because there's a lot of weight and a lot of leverage there, even though they're welded up there. In theory, they could flex that tube a little bit. So that's kind of the setup of how I'm holding things in place. And so I'll set you back here so you can get a little bit of a different bird's eye view and get the welder fired up and get this thing glued together. If anyone's interested, I'm running a solid ER70S6 wire, 18 to 19 volts, 320 feed on the wire, and a 75-25 gas mix. So let's get going. All right, so that should keep it from moving around any while I flip it over. I'll probably take a couple more looks, make sure nothing's moved. Then I'll get it flipped over and tacked on the other side. I have to ask for help because it's pretty heavy. Each one of those tubes, I bet you, is probably, maybe the long ones are, I'm guessing about 50 pounds. So there's probably roughly 220 pounds worth of material there, but I think I can just, if it wasn't for this angle iron on the end, because it sticks out, and I don't want to cut that angle iron off and waste it, I could just flip it up and flip it back over. So we'll see if I only had a gantry crane to pick it up with and flip it over. So anyway, stand by and I'll be right back. Okay, so my son's going to come over later today and help me flip this over. So in the meantime, while it's in the position that basically is going to be perfectly flat and the rest of that, I decided to go ahead and put the plates that the casters will bolt to, put those on. So I just made it to a paper template here of that's the caster plate itself with the centers of the holes. So I'm going to cut that out of a piece of plate here. Plate's bigger than what I need, so I'll prune it down. And then in essence, that gets bolted or gets welded onto the bottom of the feet, which then the casters will bolt onto that. And I think that'll actually work out better for flipping it out. I'll cut the angle iron loose temporarily. I do have, as you recall, I've got these pieces of square tube tacked on it, so that holds those correct. So I'll cut this piece of angle iron loose, or put the feet on, and then probably tack the angle back on for flipping it over, and then ultimately cut that off once all the final welding's done. So I'm just going to lay out some chalk lines here, probably cut these out with a torch, and dress up the corners a little bit and drill the holes in, and then get them welded on. Not bad for someone who's not as steady as they used to be. Okay, so I got those dressed up over on the bench grinder, and then transferred the 4 holes. Got those center punch. Instead of drilling them separate, it's easier, like I've made parts in the past, that I just stick them together, tack weld them, and just whatever you do to one, you just do to both, and that way, in essence, you're only drilling 4 holes. And then I'll split them apart, and we'll get them welded on. I might be able to save some time if I just hand drill these versus using them on the drill press, so let's give that a try. I'll have to use that drilling technique more often. So I'm going to get these, the angle cut loose here, and then what I'll do is, as I mentioned, I want the mounting plates on the same plane and flat to each other. So I'll actually clamp them, I'll get them where they kind of belong, clamp them to the angle iron, and then use the angle iron to hold them both on the same plane, bring them up against the tubing, and then tack them. I'll show you that here, but it'll be a little bit of setup, so stand by. Okay, so that's got them in position as far as a flat plane goes, but I want to make sure they're also in relation to tipping this way. I want to make sure that they're square. So I'm just going to use one of these digital angle finders. I'll put it on the tube, take that reading, zero it, and then come back and put it on this face, and that should be 90 degrees. So I'll have to tip it a little bit. That's like 88. Get the welder set up, and I'll just tip it into place, and then reach in and tack it. Alright, so that ought to definitely lock everything in. So I'll get this flipped over a little bit later when my son comes over, and set it back up and get, since this side's tacked, I'll flip it over, weld the other side up, and then bring it back, or flip it back and then weld this side up to try to limit how much things pull out of square. Okay, so I've got it flipped over here on the trailer and moved back inside, so I'm going to set you up on kind of a side view, and we're going to get this thing welded out. Okay, so that gets that one side welded out. I'm going to pause it here. I'll probably work on cutting out some gusset spacers, and then I'll bring you back. Okay, got you back down here at eye level. One more thing I'm going to add is in this area right here. If you recall, if you push weight down, these legs are going to have a tendency to want to bend out, which is the point of this one here that puts that in compression. I talked about that in the CAD design. So in extreme enough conditions, it's possible this isn't the heaviest wall of tubing. It's possible that this could try to deflect or cause this square tube to try to pull out and peel away, even though in theory it shouldn't happen because this supports it. So what I'm going to do is I'm going to put a little plate in there that boxes that tubing in and ties into the pieces. So I just held a piece of paper up there, kind of got it close, and then cut this piece out of wood to where it was a very loose fit, and you'll see here in a second. And then I place it up in there, and then I just use tape to fill in the gaps, and then I'll cut that out of steel. So that just sits up in here like that. And that kind of gets you in a little closer here. That fills that in and adds a little bit of strength to it. And it kind of finishes it off and gives it a little bit more of a finished look. So I'll cut that out. That doesn't have to be very thick material. I'll probably cut that out at just 1/8 inch and get that put in place. And then as far as now that I have it, part of it welded, I've been wrestling around a little bit to get it closer to me. It's pretty evident to me that given this tubing is 1/4 inch wall and the triangulation, that the odds of these buckling would be, in my opinion, you'd have to put way more weight than this will ever be designed for. So I originally, if you recall, the CAD drawing had a couple braces here that tied these together, and the purpose for that is to keep these from buckling in or out. But given how stout they are, I think I'm only going to put one, and I'm going to put it kind of right in this area here, which is about the midpoint. And so that'll tie it also into the square tubing over to about there. probably overkill at this point, but it will only add a few ounces, and I'm not worried about weight, so I'll get those pieces cut. Okay, the quickest way to outline this is just to lay it on the piece of steel, and I'm just going to use a little bit of light coat of paint. Normally I would make 2 of these because I'll need one for the other one, but given there could be some slight variation on that angle, just a tiny little bit, I'll just wait until I've got the second one built before I, and see how that wood pattern fits before I cut out the second one. So let me bring you over here on the bandsaw. I'll sometimes put a metal blade on the big bandsaw, but then I got to clean up the tires on the wheels, those rubber tires, because the metal gets in there. So I found it's easier just to use the portaband, and I can't remember if I don't think I did an episode on it. I'm not sure I even talked about it. I'll show you here what I did, but you can buy them actually, but another example of building it was way cheaper. I just built a stand that bolts onto where the old fence was on a portaband, and it's got a piece of square tubing leg here that I can just clamp in a vise. So that way I can use the portaband as a small portable bandsaw. And then I put you can buy these foot switches for next to nothing, where your device just plugs into this and then this plugs into the outlet. And so, because otherwise the trigger is not a on-off trigger, it's a momentary trigger, so I just have it squeezed with a pair of spring clamps, and this way I can just with my foot turn it on and off. So let me grab a piece. All right, that fits pretty good. So for those other braces, all I'm going to do is just a piece of flat bar. So let me take a look, see what I got. Okay, for these braces, all I used was a piece of 1 1/4 inch. The camera angle makes it look a lot thinner than that, but it's not. It's 1 1/4 inch wide by 1/4 inch thick. So that will tie those two together nicely. So I'm going to get those welded and then okay, so that'll wrap this episode up. Hopefully I can finish this up in one more episode where I put the top I-beam on. So appreciate you guys watching. As usual, if you like and make any comments or have any questions, that helps out. So come on back for the next episode where I hopefully finish up. Thanks again.